Hi, this is the seventh lecture of the aldehyde and ketone, and this will be the last lecture for aldehyde and ketone. All right, so last time we finished up with enamine, and we are now able to look at synthesis type of problems. So this page right here, you should be able to give me products. These are just straightforward problems in which you have either aldehyde or ketone, and then you have a way for you to react with amines, for example. Notice again, primary, secondary. Or it's a hydrolysis reaction, for example. So if you look at the H plus in water, that's what's a clue to you that it's a hydrolysis reaction. So you should be able to do all these, and what I want to focus into this lecture is the synthesis. And so you should be able to do, after today's lecture, 20.41 EG and 20.42. You have a whole section in your book on just on synthesis. So I want you to focus on reading that, and then look at the strategies, for example. It's section 20.12, and see if you could do these problems on your own. All right. So before we dive into one or two problems as an example, I want to just summarize what you have as a, I don't know why it's not as bright. I'm going to try to brighten it. There we go. I'm going to try to summarize, and this is one of the handouts that you have, in which I basically divided all the reactions into these categories on the left. So any reaction that is carbon-carbon bond forming reactions, for example, the Grignard, the Wittig, and the cyanohydrin reaction is in this box right here, right? And then in Grignard and Wittig, I also have a box on how to synthesize these reagents. For example, how to make Grignard reagents, and then for Wittig, how to make Wittig reagents. All right, and then the cyanohydrin, actually your book does it in an acidic condition, so this should be changed to either KCN and HCl, or KCN and HCN is what your book uses. This is from another book. And then acetylide ion, which you got from 114, is another way to make carbon-carbon bond formation. All right. And then this is a review from 114, an oxidation reaction. This is how you made aldehydes and ketones and carboxylic acids. So that should be a review. And this is from this unit, reduction, how to get the alcohol, either using sodium borohydride, which is a mild reducing agent, or lithium aluminum hydride, which is a strong reducing agent. Now, acetals are in this category, most useful in synthesis as a protecting group. That's why I categorize acetals under protecting groups. And then the reaction with amines, you either get imine or enamine, depending on whether you are primary, which is indicated by RNH2, versus secondary amine, which is got two R groups on the nitrogen, which means that it only has one hydrogen, so therefore it has to form the double bond with the carbon. All right, so these are the reactions that you should review. You should have note cards, 3x5 note cards, both backwards and forwards, of all these reactions, and you should be quizzing yourself almost every day so that you become familiar, and these reactions should be at your fingertips, so that when you do synthesis, they need to all be in your head so that you can pull them out and be able to come up with reactions that prepares things. All right, so I assigned you 20.42. I'm going to just briefly show you on the book what it looks like. So these are the problems. There's 8 of them, and what you're asked to do is to come up with starting materials that are no more than 2 carbon atoms. So that's the limitation, but you could start with any starting material that you desired. All right. So I am just going to do one of these problems with you, just to kind of go step by step, and hopefully the rest you could do yourself. All right. So this problem is 20.42b. And the problem is to synthesize this compound. All right, in doing any synthesis, you should first look at the product that you are asked to make, all right? And look at it and see if you could recognize the functional group. That's very important. I'm going to abbreviate it as FG. So that's the first step. What functional group do you recognize in what you are asked to prepare? All right, so right away you should recognize that this is an enamine. So therefore, you should have some idea how enamines are synthesized. So then second step is be able to come up with precursors, functional groups. So you might not be able to come up with exact carbon framework right now, but you know that the enamines are made from aldehyde or ketone, so some kind of carbonyl group plus a secondary amine, and we know that you need an acid catalyst to make this reaction happen, right? So now the third thing after you've come up with this is to come up with specific substrates that actually produce this product, all right? So in other words, do I need aldehyde or ketone? If so, what would it look like? And the secondary amine, what would that specifically look like? So secondary amine is right here, as you see. So you know that we are going to need this amine, right, in order to make this enamine. And then the aldehyde or ketone, you know that this carbon right here, where the double bond is where it used to be the C double bond O. So those are the two precursors that I need. And then see if we are done with the synthesis. In other words, what is the limitation? The limitation is that you could only start with something that's 2 carbons or less. So the amine that we have is fine because it's got 2 carbons. Now this has got 1, 2, 3, 4, 5 carbons. So we're not done yet. So we need to figure out how to make this, all right? So then it becomes basically a brand new synthesis problem in which, how do I make that? We know that we could oxidize it using PCC. So I'm doing the same 3 steps again. What is a functional group? Ketone. How do I get ketone? Ketones are made usually from alcohol by oxidation. So this is the step. And then what functional group do I see here? I see an alcohol. Alcohols, you know, are made from Grignard reactions. So what Grignard, what are the 2 things that I need in order to do Grignard? I need an aldehyde or ketone and a Grignard reagent, all right? So I'm kind of speeding along here because I'm running out of time, but you could have this carbon to be the carbonyl, and then these 2 could have added. So with 2 carbons on the MGBR, so these 2 is the Grignard reagent that has added to this, all right? So then you could show how you would have made the Grignard reagent from the ethyl bromide. And then this again becomes same problem as this, right? So we have 3 carbon long substrate, so we could redo the whole thing again with this propanol, and we could do a Grignard again with an acid. That would be the last step. So then we have MgBr plus this 1 carbon formaldehyde would give this propanol. All right, so that's how you do problems like this. So you basically, for all these questions, you're going to need to keep going backwards until you have something 2 carbons or less. All right. So quickly, I want to also give you another problem in which, let's say, they give you the starting material. So for example, let's say you're asked to start with cyclohexanone, and they want you to make this 1-methyl cyclohexene. All right, so in this case, notice there's 6 carbons here. There is more than 6 carbon here. We have an extra carbon, so somewhere I have to add a methyl group, right? So how would I do this? One way to do that is to add methyl magnesium bromide and quench it with acid. Then it would give you the right number of carbons, right? Remember, whenever you need to do a carbon-carbon bond formation, you should be thinking about these methods that you learned, right? So then, if I take this and dehydrate it, then you know that the product that we get is the more substituted alkenes. In other words, it's not going to give the less substituted, so it should give you the desired product. But flip side of that is, what if they ask you to make this, right? In this case, probably the simplest way to do this carbon-carbon bond, since it's got a double bond, is you would use Wittig, right? To do a problem like this, in which you would use this Wittig, just 1 carbon, so that you would add that carbon to the double bond to make the desired compound, right? So it really depends on which product the problem asks you to make, right? And in this example, if you did it this way, trying to make this, then you know that even though you will get a little bit of that, this is going to be a minor product in the dehydration reaction. And this is going to be the compound that you get mostly when you do the dehydration reaction, because this is a more substituted. So you wouldn't do it this way. And at the same token, you wouldn't take this and try to make this double bond using a Wittig, because it would not be easy to have a carbonyl and the Wittig reagent all in the same molecule, because you would have to cyclize it. So that wouldn't be a good way either. So you have to kind of think these things through and then figure out what would be your best option and then go for it. And you know, a lot of times you have to try it to see. Don't be afraid to just write down what you think is right, and then you look at it after you've written your synthesis, and then you can make the decision whether this is a plausible way to do this. All right. So good luck on the rest of the synthesis questions, and whatever you don't get, we could go over in class. All right. So this concludes chapter 20.